This brings us to the final session for today, which, sorry, I'm just trying to get that, there we go, which is Interledger, Rafiki, and Mojaloop. I just want to acknowledge that we've got Interledger folks. I see Chris Law, I see Brianna Marbury. Brianna is Executive Director at Interledger Foundation. Brianna, if you're able to, would you show your face and say a quick hello to the community here?
Yes. There we go. Hello, everyone. Glad to be here. I'm so excited about this. I'm super excited that we've made so much progress in bringing Mojaloop and Interledger together. And I'm glad to see Alex and Michael share out what we've come up with.
Awesome. Thanks, Brianna. I will quickly pass it back to Michael Richards and Alex. You guys take it away.
Thank you, Simeon.
Right. Okay, so hello again. I have drawn the presenting straw yet again, I think, on this one. Is that right, Alex?
Yes. Yes, I'm sorry. So. I promise I'll pick up the next one.
Okay, you all heard him, folks. He said he would definitely do the next one. Okay. Oh, this is called title. So there are two possible scenarios, we think, for using Rafiki, which is the open payments protocol, which is implemented on top of ILP in a Mojaloop system. In the first one, Rafiki replaces or duplicates some of the functions of the Mojaloop switch. Now, Mojaloop switch already uses some Interledger protocol elements, and as I've said, Rafiki is built on top of the Interledger protocol. So we did take a look and see whether it was possible for Rafiki to do some of the work that the Mojaloop switch currently does. However, we think that that's not the case. Anyway, the second is peripheral. So in this scenario, Rafiki manages transfers between institutions which don't support Mojaloop but do support ILP, and institutions which belong to a Mojaloop scheme. Now, this essentially is the adapter scenario that we were talking about earlier on in cross-network. And what will happen is that the Rafiki adapter will be an adapter, a bridgehead adapter into a Mojaloop scheme. I'm going to describe how that happens. So our investigation so far, as I've said, we don't think that the Rafiki and Mojaloop will very easily interact with each other directly. But we do think that allowing transactions to be routed from any institution which supports the Rafiki interface and the ILP protocol to use the Rafiki adapter to transfer those funds into a beneficiary on a Mojaloop network. So, as I say, our plan is to use a Rafiki-enabled proxy as a participant in the Mojaloop scheme. The proxy will manage a neighborhood which represents the Mojaloop scheme to the ILP network. Now, the ILP network is a generalized network of interactions between peers, and each of those peers speaks for, or can speak for, a domain. The idea is that the Rafiki adapter will represent a domain which contains institutions in the Mojaloop scheme to which it is attached. So that will enable other ILP-enabled institutions to discover Mojaloop institutions using the Rafiki adapter. So, transferring funds, the sending institution uses, it says ILP, but I think it should say Rafiki. Would you agree, Alex?
I feel like that's a very good implementation detail. It could use both, and we need to make that decision when we implement. But there's a short answer: it can use both.
Okay, cool. The Rafiki adapter, the Rafiki routes the request to the proxy in the Mojaloop system. The proxy manages interaction with the eventual recipient, the beneficiary, returning information via ILP to the sender, so that the sender can understand whether the transfer succeeded or failed, and also matters relating to clearing and settling. So each ILP participant records the movement of funds for itself. You'll see how that happens in the future. This is just a ledger movement in ILP. It's analogous to the ledger movements that the Mojaloop scheme records. So essentially, it just records the net obligations between to a pair of ledgers. And there is a separate management of settlement in ILP. And each ILP participant is responsible for settling with its peer using whatever settlement method is agreed between them. And now that may mean that a participant belongs to two or several settlement schemes, for instance, where it undertakes currency conversion. You'll see that in the example we're going to show you later on. And the Rafiki-enabled proxy will therefore need to belong to one or possibly more settlement schemes. So here's an example scenario, which is what we're going to use to illustrate how this will work. So funds are sent from a bank which has an ILP peer relationship with a ledger, belongs to an RTGS, and supports USD transfers in US dollars. Ledger A has a peer relationship with the bank and with Ledger B, belongs to, it shouldn't say RTGS1, that's different in the example, but also supports US dollar transfers. Ledger B has two relationships, one with Ledger A, one with Ledger C, and also supports US dollar transfers. Ledger C has a peer relationship with Ledger B and with the Rafiki proxy, and it belongs to two separate schemes. Also, it supports transfers both in US dollars and in Philippine pesos. And finally, the Rafiki proxy has an ILP peer relationship with Ledger C. It's also a participant in a Mojaloop scheme, a bridgehead participant in the sense we talked about it earlier today. It belongs to an automated clearinghouse for ILP settlement and an RTGS for Mojaloop settlement. And it supports Philippine peso transfers. So in our example, funds are being transferred from a customer of the original bank to a customer of the mobile money system. Bank's account is denominated in US dollars. The mobile money account is denominated in Philippine pesos. So we've got the Mojaloop hub on the right-hand side. Three participants attached to that, a bank, an MFI, and a mobile money system. And the Rafiki proxy, which is a full participant in the Mojaloop scheme, provides liquidity cover, settles with other participants, but its customers are in fact customers of other Rafiki institutions like the originating bank in this example. So there's the originating bank. And here is the connection between the various ledgers that undertake the ILP transfer from the originating bank to the Rafiki proxy. So that is the messaging view of how things work. And we've got a series of messages. Those are all ILP messages. These are Mojaloop messages. So the originating bank and the Rafiki proxy communicate using the open payment standard. And the intermediate ledgers communicate with each other using the ILP protocol. Okay. We'll move on and now look at how this works in the ledgers. So the originating bank gets a debit of $10 on its ledgers. Ledger A gets a credit of $10, a debit of $10, so it's even Steven. Same for ledger B. Ledger C gets a credit of $10 and a debit of 560 Philippine pesos, because ledger C is doing the currency conversion between US dollars and Philippine pesos. The Rafiki proxy gets a credit of 560 pesos and a debit of 560 pesos, and the mobile money system gets a credit of 560 pesos. So the debits and credits that appear in the Mojaloop system are just a debit of $560 from the Rafiki proxy and a credit of $560 Philippine pesos to the mobile money system. The 560 pesos, which appear as a plus on the Rafiki proxy, are the things that guarantee the ability of the proxy to have liquidity cover for the transfer when it makes it. So how does this work from a settlement perspective? Well, we've got an RTGS which manages the settlement of funds between the originating bank and ledger A, a clearinghouse which manages the settlement of funds between ledger A and ledger B, another RTGS which manages the clearing between ledger B and ledger C in dollars, and another clearinghouse which manages the conversion between, which manages the transfer of Philippine pesos between ledger C and the Rafiki proxy. And finally, we've got another RTGS which manages the settlement in Philippine pesos between the Rafiki proxy and the mobile money system. So that's how that will all work. Now, there's an open payments relationship between the originating bank and the Rafiki proxy. This means that there's a discoverability layer between them, and they can find each other across the network, and that's a network of arbitrary complexity and size. So effectively, any institution which supports the open payment relationship can find Rafiki proxies which are attached to Mojaloop systems. Under the covers, funds are transferred and settled between ledgers using an ILP relationship, i.e. the ILP protocol allows the ledgers to work out a route that goes from the originating institution to the Rafiki proxy. That's left to effectively to the internal workings of the ILP protocol, and neither party needs to know what the overall route is, though in fact they can get information, for instance, about any charges that are made by parties across the route, that kind of thing. The Rafiki proxy has got to be a participant in the Mojaloop network, and it's got to be capable of participating in settlements across that network. It may also, of course, be a participant on its own accounts with its own customers, or it may simply restrict its activities to processing transfers via Rafiki. It needs to have a peering relationship, an ILP relationship with ledger C, which of course also includes a settlement relationship with ledger C, but it doesn't need to worry about any other settlement relationships. For instance, it doesn't need to have a direct settlement relationship with the originating bank. That's all managed internally by, as you've seen, the sequence of settlements by the participating ledgers. Finally, it's possible for the Rafiki proxy to support multiple peering relationships with other ledgers, which will increase its ability to process payments and will also reduce transaction fees because there will be alternate routes for transfers arriving at the Rafiki proxy, and generally speaking, people will choose the lowest cost route. So being able to multiply routes is a good thing. So what do we want to do next? First of all, we want approval from the TGB and the DA for the architectural approach. We want acceptance for this as a Mojaloop work stream for this coming PI 19. We want to identify development resources, develop the proxy and the associated materials, tests and documentation, etc. We want to submit this for approval to the design authority, and we want it to be incorporated in the Mojaloop repository so that implementers who have participants who want to be able to implement a Rafiki relationship can just take it down and use it. So that's basically the end of our presentation. Alex, is there anything you would like to add?
I feel like this was really good. This is where we're going with. I'm really interested to see what questions people have from this, especially around how this works in both Mojaloop and Interledger. And I feel like that's the thing I'm looking forward to. Okay.
So, are there any questions or comments or interventions of any kind?
So, Michael, this is Matt. I've got a quick one around fee transparency, which,
yes,
as we all know, is sort of a level 1 principle from the very beginnings. And my understanding of Rafiki is that it doesn't sort of have that quote cycle. And so just wanted to get a sense of how we might be able to give transparency of fees prior to commitment of transactions for our user base. Thanks.
Okay, I'm gonna take this one. Rafiki actually does have a quoting cycle that happens as part of the initial handshake. You can call it the handshake, but that's part of the open payments relationship. So when you're trying to send that $10, you have a few options, and that is, do you want to send $10 or do you want the recipient to receive $10? And you set that up when you create the first connection, and the reply comes with the chosen route on how much that's going to cost you. After you get the quote, you get the option of actually start paying the quote or dismissing it entirely and not paying. So the new life cycle, ILP indeed has send packets into the ILP. That's why Rafiki is built on top of the ILP to manage this type of interaction. All the math underneath an ILP transaction or an ILP packet is handled by Rafiki. So there is indeed a quoting system and a transparency about route and costs.
Excellent. I must have misunderstood. Thanks so much.
Hey, it's Miller. I got a quick question for you. In this very long chain of money movement, when does finality occur? I know it's a loaded question.
It depends on what you think of as finality. What finality?
Oh, no. We mean only one thing, what banks mean, which is that it's my money and I can do what I want with it and it can't be reversed. So that means that once it arrives, I can spend it, literally cash it out at an ATM and it's gone.
That's it. So when the Mojaloop system pays out, that's when finality happens.
But what I'm noting is that there's a very long chain of liquidity flows through RTGSs, which are typically end of day at the earliest. And so you could be 4 days in by the time that money actually reaches the other end of the provider chain. Mojaloop only has direct agreements with its participants. It doesn't know anything about those upstream providers. It would have no reason to accept their funds or their guarantees. So that's what I'm trying to get at, is how do you bind them into this?
You don't bind anything but legacy. In the diagram Michael had, you only bind legacy, and that's a binding agreement. That settlement agreement, right? That's an actual legal agreement, and it might not happen in 4 days. That's why the Rafiki proxy credits that money into the Mojaloop system, right? And you don't have to worry about all the other ones. You're just worrying about your direct relationship with C.
So in order for this to work, that final one who is a direct participant in Mojaloop and meets the Mojaloop scheme rules and its finality guarantees is using its own working capital, as all the other providers on the system would be doing as a debtor. Then they have to arrange the appropriateness of the length of chain and participants up the chain from them in order to decide to enter into this arrangement. And so during the quoting cycle, they could decide, I don't know those guys up there at originating bank. As far as my commitment to the Mojaloop hub, I'm not comfortable with that. And so that the interledger protocol might never form for that particular transaction. But in case that it does form, there's no risk to the Mojaloop participants that it's going to not pay out in some way.
So
Because they've
that's-
already stood in for it and said, I'm going to do it.
Absolutely. So one of the things that we've said is that the Rafiki proxy must be a participant in good standing and therefore must be prepared to provide credible liquidity cover as far as the scheme is concerned for the transfers where it is a debtor.
And it's a separate study area as to the appropriateness of security around the ledger ABC and so forth. And that's within the interledger domain to sort
Yes.
that out.
Absolutely.
But that the Rafiki proxy, the blue side of the Rafiki proxy just looks like a Mojaloop participant to the rest of the Mojaloop participants. And it's the interesting business of them to blend the green and the blue in your diagram.
Yes. And is bound, as we've said, by the Mojaloop scheme's rules.
And it's also bound by their agreement with C, by their settlement agreement, or their peer. We call that the peering relationship. A peering relationship is actually a legally binding document you sign before you can peer. So that means they're only binding. They only have a binding relationship with C, and that's why C has a money transmitter license or some sort of a banking license, because technically
Yes,
they're
of course.
transferring money from the originating bank into the Rafiki proxy, right? You don't have to worry about A and B because C worries about B and B worries about A, right? And those are different relationships. And that's why settlement can happen at any point in any form. So technically, the money that left A is not the same money that hits the Rafiki proxy and might never be the same money. They'll settle in.
Right, I get that. But what we're getting at is what we want the experience of the customer of the originating bank is that they have made a payment which cleared at par in real time and is final on clearance at the Rafiki proxy Mojaloop hub to the final recipient, which I guess is one of the three other bank MFI or mobile money system participants. In other words, we would like to see that originating bank have that same experience. It's not a requirement we can enforce on them because they're not part of our scheme, but it is what would make this worthwhile is if we had an expectation that that's what occurs. Pretty much all the time.
Occurs. As them joining in the intelligent network, that is what occurs because the money leaves their Rafiki instance, leaves their liquidity cover. So essentially it gets debited out of that account, and like it leaves instantly in originating bank and it arrives 2 seconds later in the Rafiki proxy, right?
But
Well,
it arrives as a commitment
and really
it arrives as a commitment.
Yeah, I was going to say it'll be worth modeling this more than simply on desktop, but actually looking at what actual agreements this might flow through, what the reversal strategies are, what regulations apply to it. As you said, in most cases, like in the US anyway, ledger C, B, A, and the originating bank are all money transmitters in this flow. And so it's got a pretty strong rule set to how things work. However, the ACHs in the US are T+2. So money's not going to arrive immediately using an ACH. But there has to be an agreement that the IOU arrives immediately and that the IOU is essentially secure enough that clearing can occur in final form. And it would seem to me that's what we're after with the Rafiki end. I couldn't say how A, B, and C will talk to each other through ACHs and RTGSs, other than it feels a lot like Swift, which is really slow and very long.
They won't talk to each other through ACHs or RTGSs. They are exchanging with each other.
I'm sorry, I misspoke. I misspoke. I meant the money flow.
Right.
The money flow through an RTGS and two ACHs in the US is easily a week before you get to the other end of it.
I understand. But what we're saying, I think, is that, correct me if I'm wrong on this, Alex, that what is flowing between the participants are obligations which are bound by the exchange of fulfillments and conditions.
That's right. That's right.
So
I like
working,
the Swift
that's
analogy.
working in exactly the same way as it is inside Mojaloop. So the receipt of a fulfillment based on a condition that was issued by the other party is what gives each participant confidence that it really will, that the other party will make good on its obligation.
Yeah, I like the Swift analogy as well. Where Swift is just a messaging layer, this has dual layers, so it's both a messaging and a clearing layer. And that's why the settlement is not there. It's not the settlement layer, it's just messaging and clearing. The difference is where in a world where Swift messaging could happen asynchronous, this actually happens in real time. And then that's why it's faster than Swift. It's not a 2 day problem, it's a 2-second problem.
Like I said, we'd like to model it and see what really happens, because I think the expectation is that, well, I'm completely aware that Swift is a messaging layer. It is built on top of these other things, and these other things have service level agreements that slow the money down. They're deliberately trying to slow it down. That's actually their whole reason to exist, is to slow it down so that float can be entertained at each one of the stops along the way. It's not an express train, it's a local. And so if we think about how we model this, it would be useful to say how that's not the case here and why that's true. Not just that it could be that you could speed those things up, because there's a lot of commercial pressure to prevent that from occurring. And so it'd be useful to show how this is a advantage to the ecosystem and how it can actually be accomplished. That is that the outstanding loss risk that Rafiki proxy takes across C, B, and A is actually quite low, and we can show why that's true. That it might that outstanding loss risk might be same day, which is perfectly acceptable. It's no different than an ACH then in that respect through an RTGS. But I think it's exciting to see how this can be done, and that you're preserving essentially all of the useful semantics of Interledger and plugging it directly into Mojaloop without actually requiring any of the participants to even know what happened, other than the proxy. I think this is super exciting.
I feel like in an Interledger world, because you're familiar with Interledger, the proxy kind of converts a whole hub into a ledger into the system, and under the hood it streamlines this connection. Instead of having this in the hub, because we talked at the beginning of it as having that Rafiki baked into the hub, it would override or double up as a lot of the Mojaloop system. In this way, it just acts as a transistor, and it allows the entire hub to represent itself as a ledger through one of the participants inside of it, rather than having to put the entire hub on the network or all the participants in the network. Of course, this also works where there's more than one proxy into the hub, or where the proxy has multiple connections with multiple ledgers in the process.
Michael, I'm not sure if maybe it's done with questions, but Michael, do you want to? I don't see any other questions unless there is someone who wants to voice them.
Okay, in that case, I will happily stop sharing and return to my position as a mere participant.